Dear students, now we are going to see in detail of probability density function. So already we have some intro about this probability density function. So what is that probability density function means? It is a statistical description of continuous random variable. So here we can define the probability is distributed over the range of possible values. So every random variable x is characterized by probability density function. So the probability density function is established after the large number of measurements have been performed. So here how we can determine this probability density function, should remember one concept is maximum likelihood function. That means, for example, if you want to take some survey, okay, so there that maximum people are voted means, so that is the maximum likelihood function. The similar way here also, first we should know what is the possible value of that particular parameter. For example, if you want to estimate the rain, so here the rain parameter is you need to take x. So if you calculate that possible value of rain, that means which season we have more rain. So like that we need to eliminate. So here the types of probability density functions are two: that discrete random variable and the second thing is continuous random variable. So now see here, so this is the representation of discrete random variable. So now see they are having some finite set of variables, the range between 0 to 8. In that 0 to 8, so see here one values will be with the possible values will be very high and the remaining will be medium and the low average. So like that we can take the statistical average of that any parameter we can easily do. The next thing is that probability density function. The formula is between we have to set the limit from x1 to x2. The x1 to x2 may be any value. So how to write integral of x1 to x2 and p of x into dx. P of x into dx. The next thing is now we have to define the continuous random variable. So now see here that continuous random variable. So here the waveform look like bell shape. So here also we are measuring the value from 0 to 10. So at certain condition it goes to very high peak value. After that it will be get decreases. So if you want to analyze some parameters, the distribution curves is look like this. And then now the very important thing is properties of PDF. So the properties of PDF. The first thing is non-negativity. So here no event can have the negative probability. That means the P of x is greater than or equal to 0 for all x. So non-negativity. No event can have the negative probability. Thus the P of x is greater than or equal to 0. So the probability that x value exceeds somewhere over in the range of values in the certain. So it around equal to unity. For example, the second property how you can define means, if you are taking the value from some range, for example -3 to 3 or -4 to 4 or -5 to 5 means, so now how to define this? So you have to define, see here, the integral of, see here, the integral of -5 to 5. So now what you have to do, p of x that should be equal to 1. So that is the condition here you have to remember. So any continuous range of variables we can take it up, but you have to integral of p of x into dx is equal to 1. So the both properties must be satisfied by any PDF. Since the total area under the PDF is equal to 1, so the probability of x existing over a finite range of possible value is less than 1. So here that another important factor is normalization. So it is very important property in the PDF. The total area under the PDF is equal to 1. So now see here that probability calculation. So the probability that x lies between a and b is obtained by integrating the PDF over the interval. So now we are going to discuss why this PDF is important in the smart antenna system. In smart antenna systems, the random variables and the PDFs are essential for modeling noise, interferences, and fading channel. Statistical analysis enable adaptive beamforming, diversity techniques, and performance evaluation of wireless systems. And the conclusion, we can conclude this, the random variables and the probability density function from the foundation of statistical signal processing in the wireless communication. So this clear understanding of this concept is essential for analyzing and designing smart antenna systems.